Okay, this is Algebra 2, Section 2, Inequalities. This is the first unit. Let's just quickly talk about our objectives of what we need to make sure that we know by the end of the video. We're being asked to solve one variable linear inequalities, including compound inequalities, and represent the solution sets graphically and algebraically. All right. We also want to create one variable linear inequalities and one variable and use them to solve problems. So one where we're solving them, one where we are creating them from word problems, okay? So basics of inequalities, okay? Things that are not equal, all right? So things, or number, let me use numbers. Well, quantities rather, sorry. Quantities that are not equal, okay? Not equal, all right? And this is where we have those phrases greater than, less than, okay? And so we use greater than, less than, greater than or equal to, or whatever these are. I think of the shark. We'll talk about that here in a second. Okay? So, you know, what this says here, it says that two real numbers, x and y, can only have one of the following relationships. Either y is larger than x, either x is larger than y, or those two numbers are equal. You have three options, okay? The way to tell which one's bigger, you know, some people like to do the Pac-Man thing. Wah, 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 wah. You guys ever play Pac-Man? Yeah, yeah. Pac-Man's going to eat the bigger number, okay? I think of a shark. I'm a big fan of Jaws, so I think of the shark's mouth is eating the larger number. Thank you. Yeah, years of practice, okay? Or they're equal to, okay? So whatever you want. But the one, think of either the Pac-Man or the shark, whatever, okay? So it says that if x is equal to -4 and y is equal to -3/2, which relationship is true for x and y? So here's where it gets weird, all right? Now we're dealing with negative numbers. You're cool with positive numbers. You guys have been doing this for a long time, but let's take a look at this. Let's draw a number line here, okay? And I'm going to put 0 here. These are positive numbers. These are negative numbers. These numbers that are positive, the further to the right that you are on the number line, the bigger your number is. Okay, it's big. If you're further to the left, this side, they're small. Okay, so you have these numbers of -4 and -3/2. Okay, and I'm going to do this. I'm going to do 1, 2, 3, 4. Here's -4. Okay, here's this value right here. And then -3/2, that's -1.5. Okay, so here's -3/2. Here is -4. Okay, this is where it gets tricky. Dealing with inequalities that are negative, we have to think about which one's further to the left or which one's further to the right on the number line. So because the numbers that's further to the right are big, I know that -3/2 is greater than -4 because it's further to the left. Okay, so my relationship would be this, is that -3/2 is greater than -4. Okay? So it's kind of hard when you're dealing with negative numbers, but you have to think about a number line. Okay? All right. The next thing we got to talk about is a solution set of an inequality. Means that all numbers that make the inequality true. Okay? And so it asks, is 3 in the solution set of the inequality x plus 1 is less than 4? Okay? No, it's not. So, I mean, you can check by plugging these values in. Okay, I can check by plugging that in, but I would say that, you know, if you let x equal 3, okay, and you say 3 plus 1, is that less than 4? Okay, when you combine these like terms and simplify this, you get 4 is less than 4. Is 4 less than 4? No, it's the same number. This is a false statement. Okay? But what we would do, okay, in order to get a solution set out of this, all right, I'm going to do this. I'm going to do x plus 1 is less than 4. All right? Now, if I wanted to actually simplify this and get a solution set, then I would solve this like I would any other equation. Okay? I would subtract 1 from both sides, and I would get that x is less than 3. Okay? The 1 and the negative 1 go away. 4 minus 1, this right here just gives me 3. Okay? So the only values that would make this solution set true are numbers that are smaller than 3. Okay? So here's my inequality. And so my solution is numbers smaller than 3. Okay? Or numbers that are less than 3. Same thing. Okay? The book and all that, they'll use less than, but you can also say that they're smaller. All right? So, okay. Let's take a look at this next one. It says, which values are solutions to the inequality here? Now, I could take all these numbers and I could plug them in, okay? Or I could take this inequality and I could solve it. And I could say negative 3x minus 4 is less than 2. But we'll talk about solving it here in a minute, which we've already done a little bit of that, but let's go ahead and let's just plug all these numbers in and see if they hold true or not. So let me go ahead and plug in negative 4. So I've got negative 3 times negative 4, okay, minus 4. Is that less than 2? All right, so if I evaluate this, I got negative 3 times negative 4. That gives me positive 12. Minus 4, is that less than 2? No. Okay, 12 minus 4, that is going to give me 8. Is less than 2? No, 2 is small. Okay, but for some reason it's the Pac-Man's eating that, so that is false. Okay, so no. Negative 4 doesn't work. Okay. If I plug in negative 2, let's do that real quick. Okay. So negative 3 times negative 2 minus 4, is that less than 2? Negative 3 times negative 2, that's going to give me positive 6 minus 4. Is that less than 2? No. Yeah, so 2 is less than 2. That is false. Okay. No. That goes away. Okay, what if I plug in 0? So negative 3, is that going to work? Yeah, that'll work. So if I plug in 0 minus 4, is that less than 2? So that's just going to give me 0. Is negative 4 smaller than 2? Yeah, that's further to the left on that number line. Okay, here's 0, here's 2, here's negative 4. Remember, these are small. These are big. Okay, so that does work. Okay. So yes, good number. That's a good number. Okay, if we plug in 3, is that going to work? Negative 3 times 3 minus 4, is that less than 2? Negative 9 minus 4, is that, yeah. This will give me what, negative 13? Yeah. Is less than 2? Okay, and the tricky thing is, guys, is realizing that even though 13 is a big number, it's negative. Okay, again, here's 0, here's 2, here's negative 13. Okay, these numbers over here are small, these numbers are big. All right, so I was about to solve that equation, and then I realized that the notes talk about the, what you can do when you solve an inequality, okay? And they've got all these properties, and that's all fine and good. Basically, what this means, okay, the addition property of inequality, multiplication property, all that good stuff, you know, this is just how you solve an inequality, okay? And remember what I said is that we solve them the same as equations, but there's a couple of nuances. Solve them like equations. Okay, do you guys have enough room on the bottom of this page? Yeah, okay, so here's what I want to do. Let's talk about the transitive property real quick, okay? I mean, we can sit here and we can talk about all this crap. If A is less than B and B is less than C, then A is less than C. All right? So let's actually put this into context, okay? Let's say that you have the number 2. 2 is less than what? Give me a number. 4. Doesn't matter, okay? All right, you have that statement. That's a true statement, yeah? Okay. What if you said this, that 4 is less than what number? 4 is less than 6. Yeah, not 2, fortunately. That's true. Okay, so what can you conclude about this situation?
Then 2 is less than 6 also.
2 is less than 6 as well. That's the transitive property, okay? So then we can conclude that 2 is less than 6. All right, that works. Okay. The next one we have is the multiplication property of an inequality. All right. Let's try something. Yeah. Do you agree that negative 2 is less than 5?
Yeah.
Okay, is that fair and reasonable? Negative 2 is less than 5? Okay. What if I multiply both sides, okay? Let's say I multiply both sides by 3, okay? Then as a result, I get negative 6 is less than positive 15. Is that true?
Yeah.
That's true, right? Okay. Now, like I said, I mean, you guys have been doing this with equations for a long time, but these are inequalities, so we got a couple different rules here. So what I want you to write here is that we are multiplying by a positive number, okay? We multiply by a positive number, okay? What happens if I take that same inequality, negative 2 is less than 5. Let's say instead of multiplying by positive 3, let's multiply this by negative 3 on both sides. Okay? Now what happens? I end up getting, what does this give me? Positive 6 is less than negative 15. Is that true or is that false? That's false. Okay? This is a false statement. What do I have to do to make it true? Well, I can't do that because I multiplied by negative 3.
Negative 6, positive 15, just like the same thing. You just flip those. You just change the sign? Yeah.
I got to change the inequality. Okay? And maybe you've seen that, maybe you haven't. You remember that?
Yeah.
You guys have probably learned this before.
Yeah.
But in order to make it true, so to make true, okay, I have to flip the inequality. Inequality. All right, so we get 6 is greater than negative 15. Okay, so flipping the inequality, this is important. Okay?
So you can just do that any time now?
Yeah, so let's conclude this. So basically, somewhere on your paper, wherever you've got room, so when you multiply or divide by a negative, then you must flip the inequality.
So the only time you probably do that, though, like, why would you not do positive, right? So, like, the only time you do that is, like, in a problem that they give you?
Mm-hmm.
Because, like, why wouldn't you just do positive?
Right. It depends on the problem. Okay, and we'll look at a number of examples. Okay. Oh, I'm sorry. Yeah. All right, so on this next one, it says identify the property used in each step. Okay. And so basically, you know, we just got to think about if I were to solve this inequality, okay, then I would add 2 to both sides. Okay? So that would be the addition property. I'm going to call it the add prop, addition property. Okay? Here, if I would move that over, I would divide 3 on both sides. So to go from that step, I would call that the division property. Okay? Div prop, whatever. Okay? Nothing too crazy. Okay? All right, so then here, we're going to go ahead and solve this inequality here, but we have this little, you know, this thing that will help us, okay? It says first remove the grouping symbols, so we'll distribute that 2 first. Simplify each side, isolate the variable, solve and check, okay? So let's go ahead and just go through this. So on this one, we've got 2 times the quantity x minus 4 is less than or equal to x plus 15 plus 3x, okay? So I'm going to distribute my 2 first, okay? I'm going to solve this like I would any other equation, okay? So I get 2x minus 2 times 4, okay, is less than or equal to x plus 15 plus 3x. We'll do that. Okay. So we get 2x. Negative 2 times 4 gives me minus 8. This is less than or equal to. Now, I've got like terms here. I've got x and 3x. I'm going to combine those and get 4x plus 15. Okay? Now, what I'm going to do, and you can solve this a number of ways. What I'm going to do is I'm going to try and keep everything positive, at least the coefficient in front of my x positive. So because 2x is a smaller number than 4, I'm going to go ahead and subtract 2x from both sides. Okay? And as a result, I'm going to get negative 8 is less than or equal to 4x minus 2x is going to give me 2x plus 15. Okay? Now, I'm going to go ahead and move the 15 over, so I'm going to subtract both sides by 15. And that's going to give me negative 23. Okay, and that's less than or equal to 2x. Okay, now the beautiful thing is right now, I just get to divide by 2 on both sides. Okay? Because I'm dividing by a positive number, I don't have to flip my inequality. All right? So as a result, I get this. I get negative 23 halves is less than or equal to x. And that's my answer. I mean, you can. What is that? 11.5? Yeah, same thing. So negative 11.5 is less than or equal to x. Okay, now, here's the thing. All right? This is my inequality. I could also write this as x is greater than or equal to negative 11.5. All right, and there's a reason why I do that. Okay.
It's like proper.
It helps me graph it. Okay. Yeah. But what I want you to see is that the inequality symbol is still facing the x. So you do have to account for that when you do switch them around, okay? But yeah, it doesn't really matter exactly how you do that, just as long as you do it, okay? All right, yes. All right, so let's go ahead and graph this, all right? And the way I do it is I draw a number line, okay? And I put a 0 somewhere. And then I plot the point, doesn't matter where it is, I'm not really worried about the scale, but I plot the point negative 11.5. Okay? Now, because we have the inequality that x is greater than or equal to negative 11.5, because we are also greater than and equal to, because we have this little line underneath it, I'm going to put a solid dot at 11.5. Okay? Now, you can think logically about this, and you can say, okay, values for x that will make this true are larger, bigger than a negative 11.5. Okay? Has to be to the right. So you can shade to the right. All right? Now, the reason why I put x on the left and I put that x is greater than or equal to negative 11.5 is that when you have the variable on the left, okay, when the variable's on the left, the arrow shows you what direction to shade. Or you can think about it. Doesn't really matter. Okay? All right. All right, so then now, okay, let's go ahead and let's solve the inequality and then identify the graph of the solution. Okay, so I'm going to rewrite this over here. I'm going to write negative 3x minus 3 is less than or equal to 6. So I'm going to solve it like I would any other equation. I'm going to add 3 to both sides. Okay, and then I get negative 3x is less than or equal to positive 9. But then here I divide by a negative. Divide by negative 3. Divide by negative 3. So I get x. What do I have to do with my inequality symbol now? You got to flip it because you divided by a negative. So I've got is greater than or equal to negative 3. All right? So now, which one of these graphs shows that? Okay? And it's going to be which one? So we have negative 3. Well, okay, so both of these are at negative 3. Yeah, the yellow is the way it's going. So it's actually this one, right? Okay. So this is the graph. And then, so we're talking about any value that will make this true is anything that's larger than negative 3 or equal to negative 3. So the question is, which one of these numbers over here make this true? Is negative 5, is that larger than negative 3? No. What about negative 4? What about 0? Come on. 0, 2, and 4, right? Those are all in that shaded region here. Okay? If I were to plot, say, negative 4, that's over here, and negative 5 is over here. They're not in that shaded region. Okay? So these 3 are the ones that make that true. Okay? All right, some inequalities have no solutions. Let's go ahead and solve this real quick. And so let me go ahead and solve this and distribute this negative 2. So distribute my negative 2 over here. We're going to get 2x minus 7 is less than or equal to negative 8 plus 2x. Okay? And so what happens is we get this. We get a, if we subtract 2x from both sides, then they cancel out, and you're left with 0. And so, let me just write this. You're just left with negative 7 is less than or equal to negative 8. Okay? Is this a true or false statement? It's false. Kind of weird, but you have to look at it like this. Here's 0, here's negative 7, here's negative 8. Okay? This is a false statement. So if you solve this and you get a false statement, then you have no solution.
What about infinite number of solutions?
Right. So some inequalities have a solution set that is all real numbers. So in the next one, okay, if you solve this, distribute your 2, you get 4x plus 8 is greater than 1 plus 4x. If you subtract 4x from both sides, then you get that's 0. That cancels out. You're left with 8 is greater than 1. That's a true statement. Okay? When you have a true statement, you have infinite solutions. Okay? So you get...
It's true when it like can be anything. Because like not just true.
Well, when you have a true statement like that, that means you can plug in any number for x, and it will always work. You'll always get a true statement. For the original problem. Okay? When you have something over here, that means that if you plug in a value for x, you're always going to get a false statement. There are no values for x that'll make that true. Kind of weird, just a nuance. Okay? So which inequalities have no solution? X is greater than x? What do you guys think? This one's not going to have a solution because let's say you let, and just plug values in, let x equals 4. Just choose a number. Is 4 greater than 4? That's false. Because it's the same number.
What if it's greater than or equal to?
Then it would. Right. So good question. So let's plug in 4 down here into this. So if I get negative 3 times 4, is that greater than or equal to negative 3 times 4? Yeah, so you get negative 12 is less than or equal to negative 12. Because you include that it's also equal to, that's true. Okay? Down here, let's subtract the x from both sides. And we get negative 4 is greater than negative 2. True or false?
Oh, that's false.
False. Negative 2 is actually bigger than negative 4. Okay? And then let's go over here. Let's subtract an x from both sides here and here. We get that negative 2 is less than 3. True or false? This one's true. So ones that have no solutions are the statements that are false. So our answers would be this one and this one. Okay? Okay, last page of notes we've got for this section talks about compound inequalities. So that's more than one. Okay, more than one inequality. And we have this thing that says or and. Or we call a union. Okay? This includes everything. Okay? The next one, when it says and, we call that an intersection. Okay, and this is where things are common.
What's that word say? Union?
Union, yes. So like, the way I think about it, a union is like a marriage. And when you get married, typically what happens is that your whole family and their whole family, everybody comes together, and it's one big family, one big union. That's why they call it a union. Okay? Now, an intersection, I think of like before Mr. Smith knew each other, we had common friends. Okay? You guys when you get on Facebook and it says like common friends, that's like an intersection. Like you have all your friends, mutual friends, and then other people have all their friends.
You know each other kind of through like
We know each other through another person, yeah. There's a middleman. Yeah, so intersection is kind of like the middleman. Okay? All right? So how does this apply? Okay, so or means everything, intersection means union. Okay? So what I want to do is I want to solve this compound inequality. All right, so if I look down here, I see the or word, I automatically think union. Okay? So then what I have to do is I have to come over here and I have to actually solve this. So I'm going to go ahead, I'm going to add 5 to both sides. Okay? And so I get negative x is greater than or equal to positive 3. Okay, now I have negative x. I actually need to divide this by negative 1. Okay? And so as a result, I get x is less than or equal to negative 3. Okay, notice how I had to switch my sign, or switch my inequality. All right, there's one solution. Okay, let's work on the other one. All right, I'm going to subtract 15 from both sides on here. So then I'm going to end up getting 3x is greater than, what is that, 6? Divide by 3, divide by 3. It's a positive number, so I don't have to do anything with it. That's nice. X is greater than 3, or no, 2, sorry. Okay? So now check this out. Because we're talking about a union, I need to graph both of these on the same graph. Okay? So I'm going to go over here and I'm going to find negative 3. Okay? I'm going to plot that point on this graph. And it's going to be a darkened in circle. Okay? And what this tells me is that values for x are less than, smaller than negative 3. So I would actually shade in this direction. Okay? And I'm going to write negative 3 here.
For the other one, it's a hollow circle.
For the other one, it's a hollow circle because we don't include 2. Correct.
Why is it a hollow circle?
Because we don't include. So when I see this, great question. X is less than or equal to negative 3. You can include negative 3. But if x is strictly larger than 2, x cannot be 2. So what I do on that one is I use a hollow circle at 2. Okay? Like that. And I call this 2. And then values for x are bigger than 2, so I shade to the right. Okay?
So if it's
So if it doesn't have the line under it, then it's going to be an open circle?
So this means closed circle, and this is open. Oh man, I just got like the weirdest deja vu. I think it's like from a dream or something. Like, oh my God, it's crazy. I feel like I've had this exact same conversation before.
you probably have. I haven't.
Probably. I mean, I go over this stuff all the time. I'm a teacher. I know.
Actually, I have a question about the I forgot, when you add or divide or subtract from both sides, if you want to do plus 5 to both sides.
Okay, hold on. We got a good question here.
If you wanted to add plus 5 to both sides,
Uh-huh.
you get there. But let's say you had also minus 2, but also I don't know, plus 6
Okay.
on the same side, where it says negative 2.
Mm-hmm.
Would you just do that first, or would you say plus 5 and then 2 plus 5s on the right side? Do you know what I'm saying? Would you just solve the right side first and just kind of add them?
You would, I think, combine terms.
First, right?
First, yeah. Just like how you would an equation. Is you would solve it just like how you would any other equation. The only difference is that when you multiply or divide by a negative number, you got to flip the inequality.
Okay.
That's the only difference. Otherwise, yeah, it's all the same. Okay, good question. Okay, identify the graph of the compound inequality. All right, so let's solve both of these real quick. All right, has the upside down U. That means intersection. Okay, so if you have that upside down U, that means intersection. Okay. So what I'm going to do,
So does that mean that they're going to overlap?
yeah, so we want the intersection. All right. So who has mutual friends? Okay. So watch this. Okay, I'm gonna solve this first one. I'm gonna add 6 to both sides, and I'm gonna get what is that? 4 is less than 2x. So then divide by 2. Divide by 2. 2 is less than x. Okay, and I'm gonna rewrite that as x is greater than 2. Doesn't matter, but that's going to help me graph. Okay, I'm going to add 12 to both sides on this one. Solve it like I would any other equation. I get 3x is less than or equal to 22. Divide by 3, divide by 3. Oh, crap. What is that, 7.3 repeating? X is less than or equal to 7.3 repeating. Okay, so we've got that. All right, so now what I would do, I'm just going to go ahead and just graph this myself because I feel like I'm better at it this way. All right, here's 0, here's 2, here's 7.3 repeating. Okay, when I graph these, I just plot them on a graph, and I don't really care about the scale. I'm just putting them there. So x is greater than 2 means I'm going to put a open circle here, and I'm going to shade to the right. Values for x are larger, so I'm going to move to the right. Okay? It's going to go that way. All right? On the other one, x is less than or equal to 7.3 repeating. That's going to have a closed circle here, and I'm going to shade to the left. Okay? Now, I want to know, where do these overlap? Okay, where do they have a common value at?
Oh, that's where it gets helpful.
That,
Get the middle.
yeah, those are your mutual friends.
Between 2 and 7.3.
Yes. Yeah. All right, so then,
Yeah, what that means.
all right, so what is that? Is it,
Top one.
is it the top? Yeah, it's top one. Okay. Yeah, so I always shade in both directions. Okay, and then where do they intersect? Okay.
So then, like the union one, like pretty much it could be either way. So it's basically just saying like it can't be in between there. It's like the opposite.
Good question. Okay, so if it was union, okay, great question. If this was a union,
It would just be the opposite, right?
it'd be everything. Because when you'd graph, you just graph both of them down, and then that's it.
But the middle, like for the first one, like 0 is in between, so that means it can't be 0, right? For the first, like the one above this. That one, because it's like see that like empty space.
Yeah, right. Yeah, so those values wouldn't be in there.
So it's like it's kind of like the opposite, because that way it's like saying this way, it's like a little more.
Yeah.
It's a little more like reliable. You kind of like you have a better idea of what it could be. What it's like.
Yeah, well, all you're doing is just plotting where you have possible solutions.
Yeah.
So what? So the idea is that in a union, okay, in a union you'd say, okay, what values for x work in this one or this one? Okay, they have to work in one or the other.
Oh, one or the
So like if you pick 10, 10's going to work on this side, but it's not going to work on this side.
Oh, I thought they both worked, but that's 4. So then
Right.
the second one is both. Okay.
Second one, it has to be in both. It's like if you have a union, you've got friends on one side of the family and you got friends on the other side of the family, and they don't even know each other, but they're friends.
So that makes
The other one, you have an intersection of friends. You have a union of, yeah.
Is there like no way that they could possibly like go in the same direction?
Oh yeah. Yeah, you can have ones that overlap, and it just kind of extends on.
Oh, okay.
Yeah, sure. All right. There's a table here that shows all the stuff all the words. Sum, more than, plus means plus, difference, less than, minus, all that kind of stuff. But the one thing I want you to see is and equals. Those mean equal, okay? When you see the word less than, more than, you have just the standard inequality symbols. But if you says at most and at least, then you have to include those equal signs. All right, so we got a couple more questions. Bear with me. Okay, Monique makes $11 per hour delivering pizzas. Okay, pretty decent. Monique works Monday through Friday, and on average, she earns $20 a day in tips. if Monique made no less, that's an important word, than $450 for 1 week, find an inequality for the number of hours that she worked. Okay, so no less, okay, there is no less. Oh, less than. Okay. All right, so you kind of have to just put it together. Okay, so $11 per hour. Find inequalities for the number of hours. So check this out. X is equal to the number of hours. Okay, I created that. In word problems, you have to create things. Okay, so let's try this. Let's do $11 times the number of hours you work plus $20 a day times 5 days. Okay, and that's no less than 450. So is 450, is that larger? Which one's larger?
It's going to be 450 because it's no less than. So it's 450 is greater than or equal to.
Yeah.
Okay.
She said no less. But
No.
No less means that the other one would be bigger.
Yeah, no less means more.
450 is smaller than.
Oh, no, less than.
No, I got it.
She made no less. Okay, so let's, it's going to be this, greater than or equal to. Right? Or no, just greater than. Okay. Now, all right, so we have this equation, and that's the hard part, is coming up with this, okay? We had to create that. So we got 11x plus 100 is greater than 450. So then let's go ahead and subtract 100 from both sides. Word up. Mm-hmm. Yeah, exactly. Who you texting? Talk to me. I want to talk to y'all.
Well, I mean, doesn't no less mean that she can still earn 450? Just can't be below 450?
Okay, it's fair.
Yeah, that means
That's what it, yeah.
Fair. Okay, and this is 350. Okay, so then, all right, help me out. If you got your phone out, then get your calculator out. All right, so x is greater than or equal to 350 over 11. So x is greater than 31 Yeah, let's just round it up. Okay, so 31.82, and remember this is hours. Okay, so now the question is, she has to work more than 31.8 hours to make $450. Is that reasonable? If it was the other way and it was like, okay, X is less than that, you had to work less than 31 hours to make $450. Does that make sense? You have to use these to kind of help you out with the context of the problem.